Hey guys, welcome back to Unit 2.6b. This is Inverse Functions Day 2. Okay, today, in addition to finding the inverse of some of these functions, we're going to be incorporating the domain and range, and we're going to see, well, how is a restricted domain and range for the inverse function. Okay, so we've done a lot of domain and range so far. Okay, so in order to do this for inverses, we're going to find the domain and range of the original function. We're going to find the domain, and then we simply have to switch those from the original. Okay, so the domain for f of x will become the range for f inverse, and the range from f will become the domain, okay? Because remember, in the inverse, we switch the x and the y's. Okay, it's a very simple process. All right, so our first example here, we're looking at a square root function. Okay, so the first thing I like to do is find my domain and range. All right, so my domain, because it's a square root, I would have to limit to the positive numbers. So I'm looking at greater than or equal to 1. Okay, and then we know in the range of a square root function, if we take that domain value and we can plug it in to the function. Okay, that gives us the domain for, that gives us the value for our range. Okay, so my range, 0 to infinity, because this is a positive square root. Okay, so now I'm going to find my inverse. So remember, we switch out for y equals, and then we change the place of our variables. All right, so I'm trying to solve for y now. So to get rid of the square root, I'm going to square both sides. Okay, so that means that y equals x squared plus 1. Okay, so f inverse of x. Okay, so my original function, a square root, that would pass the horizontal line test. Okay, which means that my inverse is a function. Okay, and I know my inverse is a parabola, so I know that's a function. All right, so then the domain and range of this. Now, typically, a domain for a parabola is negative infinity to infinity, but you have to take into account what the original function was. Okay, in the original function, the range was 0 to infinity. It was limited. So that means that the domain here is going to be restricted. Okay, we can't actually use negative infinity to infinity because it does not support the range that it came from. Okay, and we're going to have 1 to infinity on our range because we're switching the two. Okay, my second type of function, so this is a rational. Okay, so we did see finding the inverse of a rational function last time, but we only had the variable in one place. So now we had like the x. So now we have two x's here. Okay, we're going to follow kind of the same method. There's just going to be a little bit more work to it since I have two variables. Okay, so I'm switching out for y equals. Okay, and then I'm going to change for my variable. So the reason that this becomes a little bit more complicated, you're trying to solve for y now, and you have y in two places. You have a y in the numerator and a y in the denominator. So we're going to try and get those together. All right, we saw last time with the rational function that we wanted to multiply this to the other side to get it out of the denominator. okay, because I can't work with it in the denominator, so I want to bring it up, okay? Now, the last time we did a rational function, I said that you could use two methods, but the one was a little bit more beneficial than the other because of domain and range circumstances. So we're actually going to go with, if you remember, this is method number 1 from last time, where we distribute. Okay, and we're actually going to go with that, okay, in order to solve this, because there's really no other way this time. All right, so again, we're trying to solve for y, and there's two of them. We want to get them in the same place. So what I'm going to do is add the 3x to both sides. And I'm going to subtract the y so that I can move that. Okay. So I'm trying to get all of my y terms to the left. All right, so now I need to get those y terms together, but one is an xy and the other is just a y, so they aren't like terms, which means I can't actually subtract them together. Okay, instead, we're going to do a little GCF work. Okay, so I see that there is a y in each one of these terms. Okay, so I am going to factor out a y. Okay, so take a second and look at that. So I factored out a y as a GCF. Okay, it's kind of a little trick step here. But by doing that, I now have one y on the left side. And I can check that this is correct, because if I pretend to distribute the y back in, I would get an xy minus a y term. Okay, so I know that that's correct, and I know that that's working, because I can go back and still have the same expression. But now I can isolate the y because, and you can divide by an entire expression in the parentheses if you want to take that whole thing with you. Okay, so that is the inverse. So I told you this one was more complicated because it began with an x in both the numerator and the denominator, and you had to get those together in order to actually solve. Okay, so now let's talk about the domain and range. So the domain from f of x, okay, so the domain here, I'm going to have a vertical asymptote at 3. Okay, and that's going to affect my domain. There's no holes, so that doesn't affect the domain. And then my range, okay, I know uses the horizontal asymptotes. And since the degree on the top and the bottom is equal, I'm looking at leading coefficient of 1 over 1. Okay, so my domain is going to exclude 3. And my range is going to exclude 1. Okay, so now I know for, I know for my inverse that I should be able to flip my domain and range, but I still want to check and make sure that it's correct. Okay, so I'm looking at, okay, I do have a vertical asymptote at 1, which would affect my domain, and a horizontal asymptote at y equals 3 because the degrees are equal, which means I'm looking at leading coefficients. Okay, so the domain here is going to be negative infinity to 1 and 1 to infinity, which matches the range from the original. Okay, and then I'm looking at excluding 3 here, which matches the domain. Okay, so we do see that you can switch the domain and the range between the inverse and the original function. Okay, it's not a bad idea just to verify to make sure that you've done it correctly. Okay. All right, so one more, finding the inverse. Okay, so this is a quadratic. So the domain should be negative infinity to infinity. And the range is going to come from the y value of the vertex. So this is already in vertex form. Okay, so the vertex of this parabola is 1, 4. Okay, which means that the graph would look like that. So we see that it's bounded below. Okay, so your range is going to begin at 4 and go up to infinity. All right, so we've worked with finding the inverse of a quadratic in this form. Okay, and if you remember, example number 1 here was a square root, the original, and its inverse was a quadratic. So now we're going in the other direction. Okay, and we know that the inverse here will not be a function. So we're actually going to do a little restricting to our inverse equation when we get there so that we can have a domain and range. All right, so switch my x and my y's and solve. Okay, so now that I've taken the square root, remember that nothing else can go inside. Okay, so when I move that to the other side, plus 1 is on the outside. Okay, so this is my true inverse equation. For domain and range purposes, we're just going to take the positive of the square root, okay, so that I can actually do domain and range here. All right, so the domain and range should swap. So I know in a square root, we would limit the range to be positive. So it should be x is greater than or equal to 4, and that matches what's coming from the original function. Okay, and then if you plug that domain value in to the entire thing, that gives you your range. Okay, and since we're taking the positive, this goes up to positive infinity. Okay, and now you see that this has been restricted, okay, from the original that it came from. So you do need to take that into account. So that's why I was saying don't just blindly take your domain and range. You always want to check. Okay, we can't actually use negative infinity to infinity because it doesn't produce that. Okay, taking those x values. Okay, so just with this one, I want to make a note. We don't actually have to go through the entire function, but I want to make a note that something like this, you need to make a common denominator before you find the inverse. Okay, not only is it going to help the process to find the inverse, it's going to help the process for finding the domain and the range. Okay, so we don't have to go through this one right now, but I just wanted to make that distinction for you. All right, so we did see this the last time, composing functions to prove that they are inverses. The thing that we're going to do today is two rational functions. All right, so we're going to end up with complex fractions in our composition. Okay, so I just want to go through that with you so that we see how to handle it. Okay, so these are our two functions. We want to prove that they are inverses. Okay, so that means we have to use composition. Okay, and we know that means doing f of g of x as well as g of f of x, and we get the same result of x each time. Okay, so we'll start with f of g of x. All right, so I'm going to take this guy and I'm going to be plugging it in to f. So that's in the numerator. And that's in the denominator. Okay, so now in order to simplify this, and you can do it one at a time, you're going to want to make common denominator. So a common denominator for your numerator and then for your denominator. Okay, so in the top, I'm going to multiply that by x minus 1. Okay, and just pay attention here, you are distributing a -2. Okay, and we can even do one more step here before going to the bottom. Okay, we can combine like terms on the top. So these are going to cancel, and 3x minus 2x. Okay, now we're going to go back and make a common denominator on the bottom. All right, and just pay attention here. You're distributing a -3. Okay, and then we're going to combine. So these cancel. We end up with 1 over x minus 1. So now at this point in the problem, since we have a combined fraction on the top and a combine on the bottom, we can do keep, change, flip. Okay, so that's multiplied by the reciprocal. So we keep the numerator, and then we multiply by the reciprocal of the denominator, which is not x, sorry, it's 1. Okay, I'm able to cross cancel, and so all I'm left with is x over 1, which is just x. Okay, so far so good. My first composition came out to be the answer that I needed. All right, take a deep breath, because we do have to do the other direction now. So this is a very long problem. All right, so now we're going to do g of f of x. I'm sure you were probably hoping that the first one wouldn't come out to be x, so that we didn't even have to do the second part. All right, so now we're going to go backwards. We're going to take x minus 2 and over x minus 3, and we're going to plug it into the other function. All right. Actually, sorry, I want to do that differently. All right, so there's my numerator. Okay, so I can already tell I'm gonna need common denominators. I'm gonna put these guys over 1. Okay, I'm actually gonna do the bottom first this time, just because it looks easier to me. Doesn't really matter what order you go with though. Okay, so again, just be careful. This is distributing a negative. You don't want to do all this work to have your signs mess you up. Okay, so these terms are canceling. Right, and I'm getting a 1 over x minus 3. So that's the denominator all simplified. All right, on the numerator, this 3, I'm going to put that over 1. Okay, that needs to get multiplied into the parentheses. You multiply fractions across the top and across the bottom, which means I'm taking 3 and distributing it to the top, and you would really be distributing 1 to the bottom. Okay, so we see that the bottom is really not being touched, and only the top is getting multiplied by the 3. So you really want to be careful with how you do that. Okay, because it's 3x minus 6. Okay, just carry over that 2. All right, so now the 2, I'm going to make a common denominator. All right, so the top has a little bit more work to it. Okay, so these are canceling on top. And I have x, because I'm going to do 3x minus 2x. All right, so at this point, I have a simplified fraction in the top and a simplified one in the bottom. And I'm going to do keep, change, flip. So keep the top, change to multiplication, and flip the bottom. All right, I can cancel these. All right, and 2 hours later, all right, we have completed this problem. We have proved that these two rational functions are inverses, okay, because each composition got me x. Okay, so I'm going to tell you right now, this is probably one of the hardest problems you will ever do. Okay, just make sure that your notes are complete and you write down any questions that you have. We are going to do plenty more of these in class together. Okay, so please do not panic. All right, I will see you guys next time. Thank you for watching.